Hey everybody, thanks for checking into another math video. This one is going to be about solving quadratic equations with the famous and glorious quadratic formula. Quadratic formula, actually, I was included in a sentence that starts with the word if. If ax squared plus bx plus c equals 0, then the quadratic formula says x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, you heard me kind of go into the Pop Goes the Weasel song right there. People use Pop Goes the Weasel or other songs sometimes to try to memorize the quadratic formula. It looks like it's a big deal to try and memorize that thing. It's actually easier than you might think. Pop Goes the Weasel is kind of a nice way to do it. You'll see videos all over the internet. Pop Goes the Weasel to help memorize the quadratic formula. I'm not really going to go into that so much in this video here. We're just going to show you how to use it to solve a quadratic equation, such as 2x squared minus 5x plus 1 equals 0. Well, you notice that it is set equal to 0. So let's figure out first what a and b and c are. There they are. A is 2, b is negative 5, and c is positive 1. Just a word about these three things, excuse me. The coefficient of x squared, that's what a is, all right? A is the coefficient of x squared, b is the coefficient of x, and c is the constant. We call it the constant because it never changes. The value of c, whatever it is in the equation, is always just that number, whereas the 2x squared and the 5x, those change when you change values for x. So those are not constant, but the c is constant. It never changes. Okay, enough about that. Let's try to get our formula set up here. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. There we go. And now let's put the numbers in. When you start plugging in those numbers, I highly recommend that you use parentheses and you just put everything in there as clearly and simply as possible. It is worth the trouble, I promise you, of writing it all out at first. So don't be afraid to write stuff down, okay? Notice first that we've got negative b in the formula, and our b is negative, okay? Check that out there. Negative b, that means, for our case, negative 5, all right? When you simplify that, that means positive 5. So it's 5 plus or minus the square root of, now, negative 5 squared, that equals 25, okay? Minus 4 times 2 times 1, so that's 8. So it's 25 minus 8. Before I go any further, please, just let me comment here. Negative 5 squared equals positive 25. If you put that into your calculator, let's say you're a little unsure about what a number is when you square it, and let's say it's negative, you put in negative something into your calculator and you hit equals, and your calculator tells you that it's a negative number. Don't believe it. Okay, that's because of the way you put the numbers into the calculator. Anytime you square a number, negative or positive, the answer is always positive. Okay, so I just wanted to make sure that I said that, because that is a really common place for people to make mistakes when they use a calculator. Okay, so we've got 5 plus or minus the square root of 17 over 4. Okay, so that expression right there is a pretty good answer. In fact, most of the time you can just leave your answer just like that. The 5 plus or minus the square root of 17 over 4 is perfect. However, sometimes you do want to go farther. And so let's just do that for this example here. That plus or minus means that x equals 5 plus root 17 over 4, and it equals 5 minus the square root of 17 over 4. The square root of 17 is approximately 4.1, which means that if you carry that out in the rest of those calculations there, all right, you're going to end up with a couple of other approximate values for x, about 2.28 and about 0.23. Now, why would you want to go to all that trouble to figure out those approximations? Well, here's why. One of the reasons that we solve quadratic equations is to find the x-intercepts of a parabola, and that's what those two numbers are. If you wanted to know where the parabola associated with that quadratic equation that we started out with here today, where does that cross the x-axis? It's kind of hard to tell when you look at 5 plus or minus the square root of 17 over 4. That doesn't give most people much of an idea of where the x-intercepts for that parabola are. But if you go ahead and carry them out, then you have a better idea. And so that's why you might want to do that. Okay, well, let's do another example and see what it can share, what lesson it can share with us today. Negative 3x plus 6 equals 5. Oh my goodness, that looks pretty simple. Okay, so let's set up our a, b, and c there. There's our formula, negative b plus or minus the square root of b squared minus 4ac all over 2a. Wait a second, caution, caution, red flag. What's wrong with this? This equation is not yet set equal to 0. Okay, so make sure that your equations are set equal to 0 before you figure out what a, b, and c are. That's easy to do. Just move the 5 over from the right side to the left side and it changes signs. So now you got negative 3x squared plus 6x minus 5 equals 0. Okay, are we happy? Good. All right, so now let's start putting in those numbers there into the equation and use your parentheses, write everything down. Don't try to do any mental math shortcuts yet. Make sure it's all spelled out there right in front of you. Now we'll start to work. And one of the first things you might notice is that there are a bunch of negative signs in this problem. Okay, so let's be careful with our negative signs here. All right, 6 squared is positive, so that's easy, 36. But now, when you start multiplying all that 4ac stuff and everything's negative, minus 4 times minus 3 is positive 12. And then positive 12 times minus 5 is negative 60. So we've got inside our radical now 36 minus 60 all over negative 6. Okay? All right, good enough. 36 minus 60 is negative 24. So that's what our answer looks like there, kind of simplified radical form like that. I would like to first focus on that negative, the square root of negative 24, which, as you know, is not a real number. Okay, that doesn't mean we're done. That doesn't mean we can't do anything. It just means that our answers to this equation, our solutions to this equation, will not be real numbers. I want you to just mention that in your answers when this happens for you. Just mention it. And so it's no big deal. You'll learn all kinds of tricks to deal with the square root of negative numbers next year in Math 3. But right now, writing it this way is just fine. One more thing, though, those negative 6's, the two negative signs will cancel each other out. And so there's no reason to have them both there. So your answer looks like that. 6 plus or minus the square root of negative 24 over 6. That's good enough. I would like you to say, however, that is not a real solution. I would just like to be safe in my knowledge that you know. In other words, you got to let me know that you know that is not a real solution. Okay, not a real number solution. Okay, good enough. Let's do one more and we'll call it quits. This example is all positive, so that's nice. And so when we think about A, B, and C for this in our formula, A is positive 4, B is positive 20, C is positive 25. Okay, let's put them all into the quadratic formula and see what happens. Negative b means negative 20, plus or minus the square root of, let's see, when we simplify that down, we got 400. 20 squared is 400. Negative 4 times 4, that's negative 16, times 25 is negative 400, so that means we got another negative 400 underneath the radical. So we have 400 minus 400. Wait a minute, that equals 0, doesn't it? Yeah, 400 minus 400 equals 0. So we've got negative 20 plus or minus 0 divided by 8. Just a little note here, the square root of 0 is a real number. It just equals 0. All right, so it doesn't mean you made a mistake. It doesn't mean you got a no real solution or anything like that. It just means 0. Okay, simple, clean, 0. All right, so that means then x equals negative 20 over 8, which reduces down to negative 5 halves. And that's your solution. This is an example of a quadratic equation that has two identical solutions. I'm never going to let go of the fact that a quadratic equation always has two solutions. However, as you're seeing here, sometimes those two solutions are the same number. That's okay. That fits with everything that we know. So that's what that example had to share with us. Hope you enjoyed those examples. There will be more available for you to watch, and they're all about just dealing with the little nuances of the order of operations from positive and negative numbers. Okay, so once again, thank you very much for tuning in and watching this video. I hope you all stay safe, stay smart, stay cool, and do some good math. All right, thanks. Bye-bye.